Good evening to all. So this is our 20th session and this is specifically for numerical problems and we will try to see 4 to 5 numerical problems over here in this session. So let me also try to give you if I have to give you final answers then I have to take from here. So our first problem is a water jet which is of velocity Vj impinges normal to a flat plate which moves to the right with the velocity Vc as shown in figure. So in this figure you can see this is the plate and this plate is actually moving towards right with the velocity Vc. So I can consider that and on the other hand I have a jet over here which is coming towards this plate at its velocity Vj. Okay, so I can consider, so ultimately because I need to determine the forces on the plate, if we further read the statement, like find the force required to keep the plate moving at constant velocity. If the jet density is 1000 kg per meter cube, the jet area is 3 centimeter square, and Vj and V are respectively the corresponding velocities. We have to neglect the weight of the jet. So it means weight, whatever we are having, that we have to neglect and assume steady flow. So it means whatever control volume we will be considering, there is no change within the control volume with time. Okay, and a jet is splitting into an equal upward and downward half jet. So what they are trying to say in this question, they are saying that whenever this jet is actually striking the plate, it is divided equally in vertically upward and vertically downward two halves. Okay, so maybe in this physical representation the real scenario is given how actually jet will split, but it is assumption given in the question that it is basically splitting in going in upward and downward direction. Okay, and splitting in equally in two halves. Okay, so in order to, so what they are trying to say that at this plate, so of course whenever the jet is striking on the plate, so plate should move in rightward direction. It is moving also with velocity Vc, but if we are not providing any supporting force from here, then plate will accelerate. Okay, so in order to move the plate at constant velocity, some force has to be provided, okay, from this side. So we have to determine that particular force. Okay, so ultimately you can see that in order to avoid the acceleration of the plate, I will be considering some force Fx which I have subjected on this plate. Fine. Now, if I take a control volume around the plate, so this is not nothing but a case of a moving control volume. I can consider that control volume is fixed on the plate and it is moving to the plate. Okay. So typically, if you see how we can calculate the force, for calculation of force, what I need to do? Tell me. Problem number 1. What I need to do for calculation of force? We have to apply Reynolds transport theorem on momentum term. Okay, so momentum term, what is it? Net force magnitude is equal to control volume del by del t of v vector rho dv bar. Now it should be, you should be able to tell me what is RTT. Okay, so many times we have done. Plus summation of all out mass flow rate at outlet times velocity at outlet. Okay, so m dot v out for I minus m dot v I for in. Okay, so now this is a vector equation. We can divide this equation into two components. One is fx and fy. Okay, so fx will be equal to what? Now steady state condition is given, so already I will be considering it equal to 0. So fx will be nothing but m dot in into Vx. Okay, any mass which is entering at the inlet times velocity in x direction minus, so this is inlet minus, sorry, inlet I have to take minus, outlet I have to take positive. Okay, so m dot out times Vx minus m dot in times Vx also I have to consider at the inlet and Vx here I have to consider at the outlet. Okay, so now can you tell me what will be Vx in? So you can see this is a control volume now, a moving control volume. So if absolute velocity of the jet is Vj and control volume is moving at velocity Vc, what will be relative velocity at which fluid is entering into the control volume? That will be nothing but Vj minus Vc. So this is nothing but my Vx in. Okay, what is Vx out? So now you can see this jet is actually splitting into two equal halves. One half is going like this. So say this is number 1 and this is number 2. So if I say that velocity over here is V1, velocity over here is V2. So V1 and V2 are completely in the y direction. So ultimately I can say that the Vx at outlet is equal to 0. Okay, so with this I can now calculate the, and at inlet how much mass flow rate is entering. So whatever the total mass flow rate of the jet is there, that entirely is entering at the inlet, and at outlet nothing is there because it is moving in the vertical orientation. So in x direction no mass is leaving out. Okay, so from here one more important thing I have observed, that m dot in is nothing but equal to total mass flow rate of the jet, and m dot out is nothing but equal to 0. Okay, so from here simply I can say that if Fx is the force acting on this, total force in x direction acting on this, then Fx will be equal to 0, because m out is 0, 0 minus m dot jet into, what I will be getting, m dot jet into Vj minus Vc. So this is the force which is actually acting in x direction. Okay, fine. And what will be the force in y direction? So if you calculate this particular force, can you tell me what will be mj, m dot j? And this force also I have considered Fx is acting in which direction? Negative x direction. So I will put over here minus. Yes, please. M dot out is 0 because now, right now, whenever I am calculating the Fx, then I am considering only all the mass flow rates and momentums in x direction. So if you consider this picture, in this picture you will be able to see when the momentum is striking over this plate. So from here it is entering, but from here nothing is going out in the x direction. So outlet is happening in the y direction. So that's why m dot out in x direction, not complete m dot out, I am saying here m dot out in x direction is equal to 0. Fine. Okay, so from here what will be, let me write over here also x direction. So this Fx is minus because it is acting in the negative x direction. So now what will be m dot j? Very simple, density of the jet, it is given in the question, into pi by 4 dj square, that is area, dia of the jet is given, multiplied by velocity of the jet. Fine. So this is my m dot j. Understood? Okay. So if you now substitute over here, you will be finding Fx is equal to 7.5 Newton. So simply your Fx comes out to be 7.5 Newton. Okay. What about Fy? Till now, I have, though from the physical understanding I told that we just need to apply the force in x direction. But fundamentally also we have to prove that how Fy is coming equal to 0 for this. Okay. So for Fy, what I can do, I can similarly write that Fy will be equal to m dot out in y direction into V out, okay, minus, and this is with summation, minus m dot in y direction into V in this direction. Okay, so if you see, let me consider Fy is force in the positive y direction. Okay, so if you see, what is m dot out? So m1 mass flow rate is going out, so m1 dot and with velocity v1. Okay, then I have m2 dot but with velocity v2, and v2 is in negative y direction. So that's why I will write over here minus m dot 2 into v2. Okay, and ultimately then inlet. Is there anything at the inlet in y direction? No, nothing, equal to 0. Fine. So from here you will be finding that Fy is equal to, because m dot 1 equal to m dot 2 equal to m dot j by 2. Similarly, V1 equal to V2 will be equal to how much? These two will be same. Okay, both these two velocities will be same because it is given in the question that jet is split equally in the two halves. Okay, so that is why these two will be same. So ultimately I will be getting Fy equal to 0. Okay, but if it is also asked in the question that you have to calculate V1 and V2, how to calculate V1 and V2? Please tell me. Mass conservation. Okay, so mass entering at the inlet is m dot j, fine, and mass going out will be m dot 1 plus m dot 2. So when fluid is actually splitting into the outlets, then nothing is changing. Okay, so density etc is remaining the same. Only thing is we have to consider diameter is also splitting into two halves. So area is actually changing. Okay, so I can write over here that any information is given about area. Oh, jet area is directly given over here. I thought diameter is given, but you can directly substitute the area because area is given. Okay. Jet is splitting into an equal upward and downward half jet. So we have to consider area also splitting into two halves. Okay. So by just applying now the continuity equation over here, if I solve this equation and if I make this assumption that V1 equal to V2 equal to V, because it is equally splitting into halves, then I can calculate the values of V1 and V2 also. Okay. In case it is asked to calculate in the question. Fine. Anyone is having doubt in problem number 1? Please quickly tell me, we have many problems to discuss. Okay, now we will move to the problem number 2. So in this case, water is flowing at the rate of 70 liters per minute through a flanged faucet with a partially closed gate valve spigot. So here this valve is partially closed and this particular faucet is actually connected to a flange. So you can see the half portion of the flange is shown over here, which is actually bolted. Okay, not the full flange is shown. So because we are trying to do analysis of only the faucet and we are trying to understand how much force faucet is applying on the flange. Okay, so the inner diameter of the pipe at the location of flange is, this inner diameter is how much? 2 centimeter, through which water is flowing actually. That diameter is 2 centimeter. And pressure at that location is 90 kilopascals gauge. So P1 gauge is 90 kilopascals. The total weight of the faucet assembly, so if you see the total weight of the faucet assembly plus water, so it means weight of faucet plus water is also included over here. So that total weight is how much? 57 newtons. Okay, we have to calculate the net force acting on the flange. So here it is given that, say this is my control volume which is comprising of both faucet as well as the water. Okay, in this control volume fluid is entering at this point and fluid is leaving at this point. Okay, and what we have considered, we have to calculate the net force on the flange. How much force flange is applying on the faucet? So that will be nothing but equal to the equal reaction force applied by flange on the faucet. So that's why what I have done, I have considered over here faucet as the control volume, and on this faucet I am considering that F vector R is the force which is applied by flange on the faucet. Okay, so if this is the force, then force on the flange will be nothing but just equal in magnitude and opposite in direction of the flange. Fine, anyone is having any doubt over here? So this force will be having two components. One will be Frx, one will be, other will be Fry. Now tell me how to calculate Frx and Fry. We have to consider weight also now, gravity is given. We have to also consider the force because of pressure. Okay, so let me first write for the x-axis. Problem number 2. Force in x-axis, we have a single inlet and single outlet and steady situation is there. So total force in x direction, Fx, okay, summation of Fx That will be equal to what? Mass flow rate at outlet in x direction into velocity at outlet in x direction minus mass flow rate at inlet in x direction into velocity at inlet in x direction. Okay, so now what will be summation of all the forces? So if you see in x direction, one force is Frx, which is acting in which direction? Positive x direction. Okay, then I have plus pressure force, because here if you see, this inlet is parallel to the x axis and here P1 amount of gauge pressure is acting. Okay, so P1 times area, P1 times area of the inlet A1, okay, that is acting. Then what is m dot out in x direction? So if you see, this particular faucet is completely oriented outlet in the y direction. So in x direction my outlet velocity is 0. So outlet I can consider 0 over here, minus m dot inlet. M dot inlet will be density into area into velocity times velocity. Okay, fine. Now pressure is there, diameter is given, so it means area is given, velocity is also given, I think. Oh, it is given in the question that we have flow rate as 70 lpm. So if 70 lpm is the flow rate, then how much is the velocity? V1 will be equal to 70 divided by pi by 4 into d square. D is how much? 2 centimeter. 2 by 100 square into, this is in LPM, so 1 by 1000 into 1 by 60. So ultimately from here, if you calculate the velocity, then your velocity comes out to be V1 equal to, and this will be also equal to velocity at the outlet, V2 in y direction. Okay, so this velocity is coming out to be 3.714 meters per second. And if you calculate mass flow rate, which is nothing but density into area into velocity, that is coming out to be 1.163 kg per second. Okay, now pressure you know, area you know. So from here if you calculate this, what is the unknown? Only Frx. So Frx if you calculate, it is coming out to be minus 32.6 Newton. What is the meaning? The meaning is we assumed the force in right direction, but it is actually in the left direction. So x component of force is in x direction. Point is clear? Okay. Now we have to go to the second term. What is second term? Okay, so sum of all forces in y direction. One force in y direction is Fry, which is acting in the positive y direction, minus weight is acting in the downward direction, and weight is including both. It is given in the question 57 Newton, and it is including both faucet as well as the water. So now this will be equal to any other force in y direction. M2 times V2, because entire velocity is in the y direction at outlet, minus at inlet anything is there in y direction, 0. Okay, so W is given, M2 V2 we know. So from here my Fry will be coming out to be 52.7 Newton. Okay, so ultimately I can say that the force, net resultant force, which is applied by faucet on the, flange on the faucet, that is equal to minus 32.6 I cap plus 52.7 J cap, if y direction I have taken as the vertical one. Okay, so how much force now faucet will apply on flange? Same amount of force but in the opposite direction. So minus, this will become 32.6 I cap minus 52.7 J cap. So this is the answer. Fine. If it is asked in the question to find angle, that also you can calculate. Fine. Okay, yes, please.
When the mass is leaving from the outlet, will it means the pseudo force won't it be in the upward direction due to the mass from outside?
That is what, but weight is also there in the downward direction.
No, sir. The mass movement outside is the velocity.
Okay, yes, yes, yes. Here I have done one mistake. This velocity will be minus because it is going in the negative y direction. Okay, please make this correction. So, because velocity vector is oriented in negative y direction, so I must put a negative sign. Okay, this is a vector quantity. What is clear? This should be minus over here. Now let's talk about problem number 3. Okay, so what is problem number 3? This is an interesting problem. Okay, so what we have a gate which is hinged at point O. So at point O it is hinged, it means that about point O it can rotate. Okay, and it has constant width of W equal to 5 meter. So normal to the plane of the board, it has how much width? 5 meters. Okay, the equation of the surface is x equal to y square by a. So this particular black colored line is given by equation x equal to y square by a. Okay, and where a is equal to 4 meters. Value of a is 4 meter over here. Okay, now the depth of the water to the right of the gate is 4 meter. So we have some water filled on the right of the gate and it is up to 4 meter. Okay, we have to find the magnitude of force Fa applied as shown, required to maintain the gate in equilibrium if the weight of the gate is neglected. So over here weight of the gate is neglected. So of course when this curved face of the gate is facing the liquid, so liquid will apply certain amount of pressure on this gate. So because of that some force Fa has to be applied so that we can keep the gate at its position. Okay, so this is nothing but the question related to forces on submerged curved surfaces, fluid statics. Okay, what is clear? Now how to do this question? One thing is I can find the forces on this as well, but one simple approach for this question is that, because ultimately I want to find the vertical force. Okay, so if you want to calculate the vertical force, estimation of pressure variation over this point will be actually challenging because it is a curve. So we have to link the y coordinate with the curve and that way we can calculate the pressure. Okay, so one easy approach I can show you that this is my original situation. This is my original situation. This is the free body diagram of the system. So I have water, I have gate. On this gate, Fa amount of force is acting. Okay, and of course, water is applying certain amount of force. So the force of the water on the gate is Fv in vertical direction and Fh in horizontal direction. So this is the actual situation. Now this actual situation I can split into two halves. How? First I have done that my gate is oriented something like this. Okay, so in this situation I am considering that water is here also, water is here also. Okay, so if I consider that the thickness of the gate is negligible, then whatever the pressure force will be from this side, same will be the pressure force from this side. Okay, so ultimately in this situation all the pressure forces are balanced. Okay, but what we have done, our original situation allows water only below the gate, but we have filled water above the gate also. Okay, in order to neutralize the force because of the pressure. So now what I have to do, from this situation I have to subtract the component which has come because of our simplification. So which component has come? This additional water. So I have used a minus sign over here, and now I have only considered the water which is lying above the gate. Fine. So whatever the water which is lying above the gate, this will now apply a force on the gate in downward direction as Fv because of the weight of the water over it, and Fh, a force in x direction. But if I estimate these two forces, then I can simply say these forces will be nothing but minus of these two forces. Has our situation become simple? What is clear? What we are doing over here? Okay. So now I need not to calculate for this. I need to simply calculate the forces for this. So if I calculate the forces for this, so now this is my situation. This is the curve. Okay. So water is filled up to a height of 4 meters. Okay. And force acting in y direction, Fv, that will be simply equal to weight of water over this. So I simply need to do integration in order to find out this particular volume. Okay. And what will be happening in x direction? In x direction, I will be taking the vertical projection. So this will be my vertical projection. This will be vertical projection, and this vertical projection will be subjected to horizontal force Fh. Okay. And this is nothing but a vertical plate submerged in water. For a planar surface submerged in water, what is the force? Pressure at its center of gravity times area. Okay. So what was the pressure at center of gravity? This is a plane wall, so its center of gravity will be at h by 2. So 4 by 2. Okay. So now it has become very simple. Fine. So I need to calculate Fh and Fv, and then I need to substitute these Fh and Fv with minus sign over here. Then I have to find the line of action of Fh and Fv, and then I have to take moment about point O, which will be giving me the value of Fv. Fine. So how to do this whole process? Let's do one by one. All are clear with the problem? How I have specified over here? Okay. So our first task is now to calculate Fh. Okay. So what is Fh? Pressure at center of gravity times area. Okay. Pressure at center of gravity will become rho g into h by 2. Okay. Area, what will be area? H is the total height and W is width. So this is my force. Fine. How much is the force in horizontal direction? If I do this calculation, I will be finding it 392 kilonewtons. Okay. So Fh is how much? 392 kilonewtons. Fine. What about Fy? Sorry, before this, let's also try to find out its line of action, where this horizontal force is acting. Where it will be acting? At its center of pressure. Okay. So what is the formula for center of pressure? Y. Okay, I am writing it with symbol y dash. Okay. So y dash is equal to yc plus ixx divided by area into yc. Okay. So this is the formula for center of pressure. Okay. So how much is yc? 2 meter center of gravity, plus what will be ixx? This is a planar surface. Okay. So W is width, D is depth. Fine. I think depth is D. Sorry, I am using wrong symbol H. It should be D because depth they have used with D symbol. Okay. Fine. So this is 2 plus what will be ixx? Tell me ixx. W d cube by 12. Area is W into D. What is YC? D by 2. Fine. So from here, if you calculate Y dash, it is coming out to be 2.67 meters. Fine. So the meaning is, on this portion, this force is acting at a distance of 2.67 meters below the free surface. Okay. Anyone is having any doubt? Please tell me, because this is the only last opportunity before mid-sem. Okay, next what we have to do? We have to find out Fy. How to find out Fy? Let's go over here. I have to find out this volume. So what I need to do? First thing is I need to do the integration because I have a curve. Okay, what will be limits of integration? Tell me, what will be limits of integration? So here x is equal to y is equal to 0. Here y is equal to 4. So x will be how much? D square by 4 at this point. Okay, so my limits of integration are from 0 to d square by 4. And like this I have considered some element. Say this element is having thickness dx. Okay, so tell me how much is the area. If this location is y, then d minus y is d minus y is my total height into dx into, fine, is this one clear? D minus y dx into w, because in third dimension it is how much? W. Okay, so dx is small element, dx into w is the area, and that area we have to raise through height d minus y. Total height is d, up to this point height is y, so this height will be how much? D minus y. Fine. So now how to calculate y? Let me write this one. Okay, this is only the volume. This is only the volume. If I have to calculate weight, I have to multiply this with the W. Okay, so let me write over here. Let me write over here that Fv will be, force in vertical direction will be nothing but the weight, and weight will be rho g into V bar. Okay, and rho into g is coming directly, and in place of V bar we are getting integration from 0 to d square by 4 d minus y into w dx, whereas rho g times 0 to d square by 4 and d minus y. If I replace y in terms of x, how much it will be? Root a times x power 1 by 2, okay, into w dx. Please do this calculation. Ultimately, if we do this calculation and substitutes the limits of integration, then I will be getting Fv equal to 1.2, sorry, Fv equal to 261 kilonewton. Okay, this is my Fv. All are clear with this? Now what we have to do? We have to find the center of gravity of this system. Okay, because this Fv is acting at certain location, so we have to determine its line of action in this direction. So for that, what I have done, I considered that my Fv is acting in downward direction at how much distance? X dash distance. Okay, so if I consider movement about this point O of the net resultant Fv, that must be equal to the movement of small elements over this entire. Okay, so ultimately what I can say that x dash time Fv must be equal to integral 0 to d square by 4 x times, x is for the movement, okay, x is for the movement, perpendicular distance, and rho into g is for weight, and times volume. How much is volume? D minus y w dx. Fine. This will be giving me x dash. Okay. So because of all the small elemental volumes, whatever the overall movement is created about point y, sorry, about point O, that must be equal to the moment created by the net resultant force. Okay, so if I consider net resultant force is at a distance of x dash, then Fv times x dash should be that. Anyone is having any doubt in this equation? Understood how to find out this equation? Okay, so now once I have substituted this equation, then I will be getting the value of, let me write here also this equation. So x dash into Fv equal to integral 0 to d square by 4. First x is coming for the moment, rho g is coming for the weight, and d minus y w dx is coming for the volume. Okay, so from here if you do, because this side is already calculated, only one additional x has come, so you can simply do the integration, and Fv we have already calculated. So from here x dash is coming out to be 1.2 meters. So the meaning is that this force is acting at a distance of 1.2 meter from this. Okay, so now I will come back to original situation. So in my original situation, the directions of the forces will just reverse, but magnitude will be same. So I can say that this Fv is, sorry, this is Fh. So earlier this was the direction. So here my Fh direction will be this, and it is acting at a distance of how much? Y dash away from the point O, and this Fv is now in upward direction and it is at a distance of x dash from point O. Clear? All are clear with this point? So if I know these two forces, I can now simply take the moment about point O. What will be moment about point O? Tell me. This distance is how much? 5 meters. So Fa is acting about point O in counterclockwise direction or clockwise direction? Clockwise. So minus Fa into L, okay, plus Fh into Y dash, not X dash. Fh into Y dash. Will it be plus or minus? No. Fh is in counterclockwise direction, so it will be plus. Okay. Then Fv is in which direction? This is again in counterclockwise direction. So plus Fv into how much? X dash, and this is equal to. So from this I can calculate the value of Fa. Let me write it again over there. Fa times L has become Fh times Y dash plus Fv times X dash. Point is clear? Is this point clear? So from here ultimately I will be getting the value of, let me check once again. One mistake we are doing over here. Y dash was the distance when we measured from the free surface. Okay, so this distance was Y dash. With reference to point O, how much will be the distance? D minus Y dash. So whenever I am considering Fh, I must write over here D minus Y. Point is clear? This is a mistake which we have done, because Y dash is center of pressure, that is always measured from the free surface. Okay, you can see over here. Please make this correction. I must write over here D minus Y dash. From here if you calculate, then Fa is coming out to be 167 kilonewton. So now you can do all the problems of forces acting on submerged power surfaces. Okay. Fine. Okay, let's see the next problem. Very simple one. This is from the concept of buoyancy. Okay, but very simple problem. I think you can try by your own. How many of you have seen this practice sheet 2? I have already posted on Moodle. Done. Solved the problems? But you asked yesterday that you want to solve. Okay, so we have hot air balloon approximated as sphere of diameter 15 meter. Okay, and we have to lift a load of basket load of 2670 newtons. To what temperature must the air be heated in order to achieve the lift off? So the question is, we are considering that we have a sphere and this sphere is of 15-meter diameter, and to this some basket is connected. Okay, and this basket is having total weight of 2670 Newton, only the weight of basket. Okay, so we have to lift this off. So of course this is filled with air. Okay, so we have to, if we heat the air, then its density will become low. Okay, so it must rise. So at what temperature we should, up to what temperature we should heat the air so that it start lifting off? So when it will be lifting off? Critical limit of lifting off. Buoyancy and weight are becoming equal. Okay, so let me write this. Weight is first weight of basket, weight of basket plus weight of, because sphere is big, 15-meter diameter, so we have to also consider the weight of air. It can be significant. Okay, so plus weight of air, that is equal to buoyancy force. Please, how much is this? 26. What is weight of air? Density of air. How much is the volume? Pi by 6 dq. Sphere. What is the volume of the sphere?
4 by 24
Pi by 6 and dq. So you want to write in more complicated form. Pi by 6 dq times gravity. Okay, this will be equal to how, what? So this is not density only, this is density of hot air. So hot air, because inside balloon there will be hot air. Okay, then this must be equal to buoyancy. Here it will be coming density of atmospheric air, because ultimately this balloon is displacing atmospheric air. So buoyancy is coming because of the displacement of the atmospheric air. So density of atmospheric air times volume is pi by 6. Density of atmospheric air I know. So all the quantities I know. From here what I will be getting? Density of hot air, that is coming out to be how much? 1.073 kg per meter cube. What I need to do now? Now comes the assumption. Yes, we will consider now air is an ideal gas. For ideal gas, P is equal to rho RT. R is constant. Pressure is also, we are considering it is same atmospheric. So what I will be getting? Sorry, pressure I cannot consider constant. So from here what will be happening? Okay, let me write it. P by rho T for hot air must be equal to P by, let me write rho RT also. P by rho RT for atmospheric air. I can write from this equation. Okay. So now what you can do, RR you can take constant, And you can also assume that pressure is also not much pressure difference between the within the balloon and outside the balloon. Okay, so from there your density and temperature will only come into picture. Density you already know, atmospheric temperature you can assume to be 25 degrees Celsius. Corresponding to that, or I think in this problem, okay, it is not given, but ultimately I have noted down the answer for hot air. So that should be close to 56 degrees Celsius, and I think this answer is coming when temperature of atmospheric air is assumed 15 degrees Celsius. Okay, verify this. Okay. So if you heat up to 56 degrees Celsius, slightly above that, then balloon will start lifting up. Okay. Next problem, very simple. So first we have discussed fluid dynamics, then statics, now it is kinematics. Okay, so this is from the fluid kinematics. So here we have a viscometric flow in the narrow gap between large parallel plates. So we have two parallel plates, one plate is fixed, other plate is moving with velocity u to the right, and the velocity field in the narrow gap is given by v vector equal to u into y by h, where h is the gap between the plates and y is coordinate in the vertical direction. Okay, so vy by h of I cap, this is the velocity in the x direction. So in x direction velocity is varying, and you can also see over here this velocity field is actually shown in this particular schematic. Okay, at time equal to 0, line segments AC and BD are marked in the fluid to form a cross as shown in figure. So here you can see this is the line segment AC, their coordinates are given, this is a horizontal line, and this is a line segment, vertical line segment BD. So at time t equal to 0, these are looking like this, okay, forming a cross mark. We have to evaluate the position of the marked points at t equal to 1.5 seconds. What will be the new position of all the points A, B, C, D? Okay, and we have to sketch the comparison that how our new point will be looking like. Okay, and then we have to also calculate the rate of angular deformation and rate of rotation of the fluid particle in this velocity. So this is a question of fluid kinematics. Okay, so can you tell me how to determine the new positions? So one time is t equal to 0, other time is t equal to 1.5 seconds. What is delta t? 1.5 seconds. And flow is only in the x direction. You can see the flow is only in the x direction. But at different locations of y, velocity of the flow is different. Okay, and that is given by u equal to capital U times y by h. Now at point 1, what is the value of y? 2, and h is given how much? 4 mm. Okay, and u is given equal to how much? Any value of u is given in the question? U is equal to 4 mm per second. Okay, so let me calculate the velocity at point A. Please tell me what is velocity at point A. Four mm per second times 2 by 4. So it is coming 2 mm per. Okay. Now this is velocity only in x direction. So how much will be the this VA, or I must write over here UA to just show that velocity in x direction. So UA must be equal to delta x by delta t. Okay. So from here what will be delta x? 2 into 1.5, which is 3 mm. Okay. So what is the new position in x direction? So it was at 1 plus 3. This is delta x. Okay, so 1 plus 3. So I can say x dash a is nothing but equal to xa plus delta x, and that is 4 mm. The way I have shown it for this point A, can you do it now for other points? Very simple. Everywhere for calculation of velocity you have to use y coordinate, and for Displacement, it will be only of x coordinate because velocity is in the x direction. Okay, so let me show you the final answer for this part. So you can see this was the fluid element at time t equal to 0. These line segments cross mark, and this is the new orientation of the cross mark. So what is happening over here? You can see in x direction only the translation, sorry, for this segment A and C, which is parallel to the flow, here only the linear translation, but for segment B and D, which is normal, so its two different ends are subjected to different velocity. This is at faster velocity, this is at slow velocity, so it is tilting. Okay, so it is tilting like this. Fine. So while it is tilting, we can say that it's stretching in normal direction. So you can see this was the original length, now this is the new length. Okay. So next is you have to calculate rate of rotation and rate of angular rotation. So what is rate of deformation? Please tell me. Have you not prepared for your midsem exams? Rate of deformation is del u by del y plus del v by del x, and if you calculate it, it comes out to be u into 1 by h plus 0, and the answer for this is 1 per second. Okay, and what is rate of rotation? Omega z, xy plane is there, so it will be in the third direction, that is half of del v by del x minus del u by del y. If you do calculate, minus 0.5 second inverse. Okay, so this is it clear? Any doubt? Enough. Okay, so it means that we have done statics, kinematics, dynamics. So all your preparation for mid-semester exam is over. Okay, so this is so important session. Those who missed it, they have to prepare by themselves. Okay, so for you people, your preparation is already over. Okay, so earlier I told you that one important application of the fluid dynamics is actually in where? Measurement of blood pressure. Okay, so we are having biomedical devices also which we use. So you all have seen that when you go to a doctor, he puts some cuff over here and then he do some pumping and then listen something and then tell you whether your blood pressure is normal or not. Okay, so can you tell me what is the normal blood pressure range for a healthy human? 120 by 80 or 110 by 70, something close to that. Okay, so what does these two numbers represent? So if I talk about the first number, the top one, that is called as, and bottom one is called as diastolic. Okay, so systolic means when your heart is in the completely compressed state, at that time whatever your blood pressure is there, that is your actually systolic number, and diastolic is whenever heart is in the relaxed state, then what is the pressure inside your blood vessel, that is your actually diastolic. Okay, so how to measure blood pressure? What doctor does first doctor identifies your brachial artery. Okay, so brachial artery is nothing but a main blood vessel. So this is our main blood vessel which brings blood from our heart to our fingers, hand, etc. So whatever the main blood vessel passing through this portion, that we call as our brachial artery. Okay, so what we do basically, first we, if say this is the normal opening position of brachial artery, then we will be having some flow of the blood over here. Okay, in normal situation. If I now compress this brachial artery. If I compress this brachial artery, what it will be doing? There will be some situation, if I compress above the systolic range, then for some time my flow in the brachial artery will be completely stopping. Okay, if I compress it above the systolic range, because your heart can only provide blood up to this much pressure. Okay, so if we are compressing it above that, then it will be completely stopping the flow. Okay, so if first what we do, we first completely stop this one. Okay, and then after that we slowly start relaxing that. So initially doctor pressurizes your cuff, and then slowly he or she releases the pressure. So once they are releasing the pressure, then they are actually creating small opening through this. So when this small opening is there, then your blood is coming at the speed, and it will create some sort of turbulence over here, and it will strike against the walls of the brachial artery. So because of that, some sound is created. Okay, so whenever doctor starts slowly releasing the pressure of the cuff, and the point where he or she listens some sound, corresponding to that sound, whatever the value of pressure is there, it means that sound is significant, that now flow of blood has started through that point. Okay, so that is nothing but our systolic. And when we keep on releasing, the point up to which we, so you will be finding at this particular point, systolic number, the intensity of sound will be very high. After that, slowly it will start decreasing, and the point where it completely disappears, that is the point where your blood vessel has become completely relaxed and your blood flow has reached to the normal situation. So that is nothing but your diastole. Okay, so today I have got this blood pressure machine also over here. So if anyone of you wants to see how to use it, I can show for one person, and then you people can also try by your own. Okay, and this will be kept in the lab of fluid mechanics. So if you people want to use how to learn how to use it, if you want to learn, then actually you can check your blood pressure by your own. Okay, and you can also verify by measuring. Multiple person can check the blood pressure of a single one, and then you can find out the uncertainty which is associated with the human error, because different person can have different hearing capacities. Okay, so we will stop now.